In this quick video tutorial, I'll show you how to get started with the millimeter wave RadarIQ sensor. We'll start by opening the package. Here you'll find the RadarIQ-M1 sensor, a half meter USB cable for connecting to a PC, a half meter cable for connecting the sensor to an embedded electronics device such as an Arduino or Raspberry Pi. Following the instructions on the box, we'll head to the RadarIQ website to download and install the controller software, which is available for Windows, Mac and Linux. The controller software allows you to view the output of the sensor as well as change settings. For your own applications, we provide C and Python SDKs, which are available from our website. I'm going to plug in the RadarIQ sensor and fire up the controller. Here's the area where the data will be displayed. The x-axis shows distance to the left and the right of the sensor, with negative numbers indicating towards the left and positive numbers towards the right. And the y-axis indicates the distance away from the sensor. Before explaining any of the controls, I'm just going to start the sensor so we can get an idea of what the data looks like. As you can see, two detections are shown here. This is the ceiling above my desk, and this here is some of the equipment that I've got sitting around the desk, such as the screen. Radar sensors give quite different data to camera-based vision sensors. Radar sensors only see objects, and this is visualized as a sparse point cloud. Here is an image taken from our manual of a car driving. As you can see, the only thing detected is the moving vehicle. The RadarIQ sensor has a 110-degree field of view in the azimuth direction, which is to the left and right of the sensor. It can also see 15 degrees in the elevation direction. The sensor also measures velocity and intensity of the detections. Before going further, let me come back to the controller software to explain some of the other features. Looking down the side panel, you can see a range of settings to adjust parameters of the sensor. We can adjust the frame rate. This can be arranged from 1 frame per second to over 20 frames per second. A default of 10 frames is a good place to start for most applications. Next, we have the sensitivity setting. This adjusts how sensitive the sensor is. High sensitivity will detect more objects, but is also prone to false positives. Next, we have point density. Sometimes reflections are weak and don't produce many points. To increase confidence in detections, the point density can be used to aggregate several adjacent frames together before any processing algorithms are run. Moving down to the filter section, we can filter on distance, angle, height, and moving. The distance filter restricts detections to a particular range. Often detections close to the center are not interesting. There could be other equipment or an enclosure around the sensor which causes unwanted detections. By setting a minimum distance, this will remove these. This can also be useful for focusing the display to a particular area. Here you can see I've focused in on the ceiling. And this is also illustrating another one of the RadarIQ features, the ability to see through walls. Here you can see two distinct areas of detections. The first is the ceiling and the second is the roof. Next we have the angle filter. The RadarIQ sensor can see 110 degrees, which is 55 degrees to the left and 55 degrees to the right. This viewing angle can be changed to focus the field of view. Third is the height filter. The height filter can be useful if the sensor is mounted low to the ground. By applying the height filter, the ground can be ignored. The RadarIQ sensor has the ability to filter to just moving objects, ignoring static ones. This is great if you're only interested in detecting movement. As you can see by enabling this feature, the detection points disappear, but if I wave my hand above the sensor, then that's detected. Finally, we have the set buttons. Set will apply the changes to the sensor. However, when the sensor is repowered, the settings will revert back to the previous defaults. Set as default will apply the changes, but only save them as the new default, which is loaded every time the sensor is powered on. One last thing worth mentioning is scene calibration. As we can see, the sensor detected objects sitting on my desk. In your application, there might be equipment near the sensor which you'd rather was out of the sensor's field of view. This is where scene calibration comes in. Scene calibration performs a scan 1 meter in front of the sensor, looking for any detection, and then essentially does a background subtraction on any subsequent data. When running scene calibration, it is important that there isn't anything in front of the sensor which should be counted as a real object. For more information on how to use the RadarIQ sensor, check out the manual and sample applications which can be found on our Getting Started page. If you have questions or simply want to share your project with others, head over to the RadarIQ forum. I hope you enjoy working with the RadarIQ millimeter wave sensor.